Okay guys, in this video we're going to talk about zeros and how that zeros sometimes are act as placeholders and sometimes zeros are actually part of a measurement when we're dealing with these measured values and precision with our numbers. Okay, so to do that we're going to do a few practice problems, just kind of get our mind kind of thinking the right direction. So first one here, find the surface area if the length is 45 centimeters and the width is 62 centimeters. Okay, so we're finding area here. So if you take 45 times 62, that gives you 2,790 centimeters. However, that number 2,790 centimeters squared, if you look, this only has two significant figures in it, and this number only has two significant figures in it. So we have to find a way to report this number with only two significant figures in it, or two measured values. Now right now, depending on if you count this zero as part of the measurement or just a placeholder, you would say it has either 3 or 4 measured values in it. What we want to do is take this number and round it to the first two non-zero numbers. So to the 2 and the 7, the 9 makes us round up. So we'll round it off to 2,800, and then these two zeros become placeholders and not part of the measurement. Okay, if we do the same thing down here, 1.23 grams and 3.1128 milliliters, and we do that math, we get a very small number, and again, we only have three significant figures or three measured values to work with, so we want to round this to a place where it has three of those. Again, if we kind of skip over these zeros, we find our first non-zero number, and we find 1, 2, 3 values there for three significant figures, and we round it to 3. Okay, so in these two scenarios, we're trying to set up the zeros as placeholders. However, there are cases where zeros are also part of the measurement. So we have to have a system in place that allows us to determine when is a zero measurement and when is a zero part of the just a placeholder. One more example for us. If you have 0.0055 kilogram mass and you're going to divide that by 6,500 milliliters to get a density, and we solve that, we get this really outlandish number. Now, all these zeros up front could be placeholders, but maybe we want them to be part of the measurement. It's kind of hard to tell. We have a bunch of zeros out front here, a bunch of zeros here. So without knowing the rule system, it's really hard to tell, well, where do I round this number off? If I take this very small number and divide it by a very big number, do I really round it back? Do I really round it back to just being 0? Or do I round it to the first values over here? Okay, so we just need some rules to help us through this process, is essentially what goes on. Okay, so if we take and go to our next slide here, this slide now gives us our rules in terms of what we need to do in terms of rounding for zeros. The first line here in black that's underlined isn't really a rule, it's more overarching concept. So zeros used only to locate a decimal are not measured. Okay, so if we're using a 0 for the point of just holding the place value of our measured numbers, then they're not considered part of the measurement. Now, if the zeros are being used as a measurement, then we do need to consider them. So really, this doesn't help us in determining anything. It just kind of reminds us of what we're trying to accomplish here. What's in red, blue, and green are our rules that help us determine what's going on. So we've established a set of rules that basically tells us if we look at this from this perspective and everybody does it the same way, then we all know what we're writing, we all know what we're communicating with each other. Now, these rules here you're not going to find in a textbook. The reason being is I've rewritten them more through the perspective of let's just figure it out, and there's actually make it more simple than you're going to find in a typical textbook or online resource. Okay, so what I always say is let's look to see do you have a value that is greater than 1 or less than 1. Okay, so your first step is, oh, is my number bigger than 1 or less than 1? Okay, so if it's bigger than 1, then we look to see, is there a decimal on it? If there is a decimal on it, then all values, including the zeros, are part of the measurement. Okay, so numbers bigger than 1 that include a decimal point, for whatever reason, all have the zeros as part of the measurement. If there is not a decimal, the zeros that are locating the decimal are just placeholders. Okay, now this doesn't mean that you can't have zeros that are not part of the measurement here. We're talking about the zeros that are the trailing zeros or the ending ones or the ones using to locate a decimal. If you have any zeros between some other numbers, like you have 2, 0, 2, and then 0, 0, 0, In that kind of case, the 0 between the 2's would still be part of the measurement, just the ending zeros would not be part of the measurement. Okay? For numbers less than 1, only the zeros written to the right of the first non-zero are part of the measurement. Okay? What that means is all those leading up zeros to the left-hand side are just placeholders all the time for this. So it's not as much thinking here, it's just always the same rule every time for numbers less than 1. When you have scientific notation, it can really help us in terms of identifying our significant figures in our measurements here. All zeros written in scientific notation are part of the measurement. Okay, so what scientific notation does, it allows us to drop off or to remove any placeholder zeros. So if we don't want a zero to be part of the measurement, we just don't write it. Now, if we want a zero to be part of our measurement, we include it in the scientific notation process. Okay, so actually, scientific notation kind of becomes our friend. So it really is used to help us find the right measured values. We're going to do some practice here. We're going to start off with underlining the measured values. You'll notice how there's a bunch of 5s and a bunch of zeros here. Hopefully, you'll underline all the 5s because if it's not a 0, it's part of the measurement always. And then the real goal here is some of these zeros are part of the measurement, some of them are not. So go back to our rules and apply these rules to figure out if these zeros are part of the measurement or not. Once you have that part done, come down here, and we're going to assume that these numbers came from a calculator screen, or they came after you've done a calculation and now you have an answer. And we want to round them all to 3 measured values or 3 significant figures. Now, none of these are at 3 right now, so we have to make some changes to make them match that number 3. Okay, this would quite often happen if you, let's say you had a number that had 3 significant figures in it that was measured. You did some math with it, and then now you have to, the answer you get from that math needs to be rounded back to the right precision. Okay, so this is something we've done before, but now we just include zeros to make it a little bit more challenging. Okay, so do this, and once you're done, then unpause the video. So pause it now, and then that way I'll go over the answers. Okay, so now that we've gone through this, let's go through the answers. We have, if you notice, all the 5s are always underlined. And then in this scenario, these zeros were the zeros of a number bigger than 1 with no decimal. So these zeros are just going to be placeholders, not part of the measurement. Same thing here. You have a number less than 1, so the zeros to the left-hand side are just placeholders. Down here, we have a number bigger than 1, but we see a decimal, so everything is part of the measurement. Down here, again, is no different than this one, except for our zeros trailing to the right-hand side are part of the measurement. Over here, it's just like number 1. Number 6 is kind of a combination of 1 and 2, putting them both together. Number 7, we see something in scientific notation, so anytime you have a 0 in scientific notation is part of the measurement, so that gets underlined. And number 8 is kind of another way of doing scientific notation without doing the fancy stuff. When you see a number with a word written after it, that word represents a whole bunch of zeros. Those zeros are never measured. Okay, so they're all part of just basically placeholders at that point. So we only have 2 measured values in this. Now coming down here to round it, first one we got to round off, so we just get 551. Second one, we could round it and write it one of 2 ways. We could write it as 0.00325, or we could put it in scientific notation as 3.25 times 10 to the negative 3. Third one, same idea, but now we're going the other direction. So we want to have a few placeholder zeros in here on the right-hand side, or write it in scientific notation, and you notice how those placeholder zeros go away. Fourth one, we round back, and it just happens that the 0 is in the position of the third measured value. So we do want to keep this 0 there because it is part of the measurement. These zeros over here would not be part of the measurement on this one. 5, 6, 7, and 8 are a little bit more challenging. So they're there kind of to push the limits of what you kind of maybe understand with this stuff. We wanted this number to have 3 significant figures in it. So the 5, and the 0 all have to be significant. So to do that, we have one of 2 options. We can put a decimal on it. It may look a little ugly to you, but it does work. Because by putting a decimal on it, we now have changed our rule, and we have a number bigger than 1 with a decimal. So now this 0 has been included in the measurement. Or if you don't like this, just write in scientific notation and include the 0. For number 6, because we wanted to have one of the zeros as part of the measurement, but none of the other ones, you have to use scientific notation. So the only way you can get a number that has some zeros measured and some zeros not before the decimal is using scientific notation. Okay. The last one, or sorry, it's number 7. This is one that is quite often a test question. I give somebody a number that has less than 3 measured values and tell you to go to 3. And people might say, well, you can't do that. You can't add in precision. We're really not adding in precision. We're actually just bringing the precision back to where it belongs. So there's often times where a calculator will give you a simple answer that doesn't go out far enough, and you need to maybe put some zeros in as part of the measurement. This happens most of the time when your number is close to or less than 1. But it is a case where you need to add in some zeros to get some precision here for this one. Okay. And the last one, again, we're just using scientific notation. The 5.50, this is part of the measurement, so then we now have 3 significant figures for this. Okay. If you want some additional practice on this, worksheet number 3 has a lot of good practice with this. It has some similar questions like this, but then it also has, I think, 8 additional calculations with rounding involved with it that requires you to use this over and over again as practice. Okay, so it's a really good resource to spend some more time practicing this and making sure that we understand it. Okay, thank you.